Okay, so you should be able to see the screen. So on the first page, I have listed all the trig identities that we are going to be able to use in order to prove these statements. So what is a proof? Well, I'll look at that on the next page. Okay, so the top identities are the reciprocal identities that we have used. So we know sine, cosine, tan, and these are the reciprocal ones. Note that I put here tan is sine of a cosine and cotangent is cosine of a sine. Those tend to be more useful than putting cotangent equals 1 over tan. Generally, because of our strategies, those are the better version. So I would tend to use those more than 1 over tan or 1 over cotangent. These are the three Pythagorean identities that we used last year in grade 11. So the identities up to here are the ones you used in grade 11. So in grade 11, you just use those top ones. The bottom ones are new ones for grade 12, right? So these are our double angle identities, and these are our compound angle identities. So we can use any of these identities to prove these statements. So when you're doing identities, I would have this in front of me, okay? So you have it, it'll be posted on the lesson, so you can print it off. I'm not sure if there's one in the guide, but you can print this off. Just download it onto your device and then just print it off, okay? So I'm going to erase things so that when you print it, it looks better. Okay, so let's just erase all this so you get a nice clean page. Okay. All right, so a trig identity is a mathematical equation that is true for all values. So in order to prove it's true, you want to prove that the left side is equal to the right side. Okay? So things to keep in mind. You can only work down one side at a time, but you can work on both sides. So if you work down, let's say, the left side and you get stuck, you can move over to the right side and work down that side. There's no rule. Some teachers like you to only work down one side. I don't really think that's necessary. So you can work down either side. You can work down both sides. You can work down the left. You can work down the right. You can work down both. What you cannot do is move terms from left to right or right to left. So remember that, and you'll see I have a table here. Because you are trying to prove the statement is true, you have to work down each side individually. You can't bring terms over. It's not an equation. You're just trying to prove that the statement is true. So generally, we either use a table or a T-chart because you should not have an equals in between these. It may be tricky when you're typing these up, so I'm going to overlook that. But generally, when you do a proof, you say left side equals, right side equals. We don't write an equals in between because we don't know it's true yet. So you can't make that statement that it's equal until you've proven it's equal. So that's why we work down with proofs. We work down left side, right side, but we don't say they're equal to each other until we get them equal to each other at the end. Okay? So sometimes we like to do it in a table like this. So this will look familiar to you from grade 9. So in grade 9, we solved equations and then we checked our answer. And so we used a left side, right side check. So we put our answer in the left side, we put our answer in the right side, and we wanted to see if the left side equals the right side. So that's basically what a proof is. You're trying to prove that the left side is equal to the right side. So you can't prove, or you can only work down one side at a time. You cannot move terms from one side to the other. You can work down both sides. So if you get stuck on one, you can go to the other side. Okay, so those are sort of logistical strategies. Some strategies to use when starting your proof. The first thing I generally do is express all my terms in sine and cosine if they are not in sine and cosine already. After that, we want to simplify. So there's lots of things we can do to simplify, and I'll try to do examples of all of them. So we could expand, we could factor, we could find a common denominator, we could replace things. Okay, that's why people find trig identities a little tricky, because everyone is different and has different strategies for different proofs. Okay, and then generally we try to do the complex rather than the simple. So when I look at my So let's look at this first one. I want to prove that sine x times secant x times cotangent x equals 1. Well, on the right side is the 1. I can't do anything there, so I'm not going to work on that side. I'm going to work on the left side. So my first strategy is to change everything to sine and cosine. So we've got sine x, okay, that's okay, times secant. So I change secant to 1 over cosine. And cotangent, I change cotangent to cosine over sine. So I'm looking at this. I changed secant to 1 over cosine. I changed cotangent to cosine over sine. So that's my first strategy. If it's not in sine or cosine, change it to something that has sine or cosine in it. And then I look to, how do I simplify? Well, this one I can just reduce. Okay? So sine reduces with sine, cosine reduces with cosine, and my answer is 1. Therefore, the left side equals the right side. Okay, that's a very basic proof. Change to sine and cosine. What can you do to simplify? In this case, I can reduce. Okay. All right, so on the left side, we have 1 minus cos squared. On the right side, we have tan x times cosine x times sine x. So I'm going to start on the right side by changing tan. So on my trig identity sheet, I see that tan is equal to sine over cosine. Let's draw a line here. So tan is equal to sine x over cosine x. So I'll change that, and then I have cosine and a sine. And then I ask, well, what can I do to simplify this? Can I reduce? Can I expand? Well, I could reduce the cosines. And then I'll multiply sine x times sine x gives me sine squared x. So they don't look the same, but when I go back to my identities, I know that sine squared x is equal to 1 minus cos squared x. So I can change either side. Doesn't matter which one. I can go on the left and change 1 minus cos squared to sine squared, or I can go on the right and change sine squared to 1 minus cos squared. Doesn't matter which side I change, as long as the left side is exactly the same as the right side. Once that happens, I can say, therefore, left side equals right side. Okay, so keep in mind that sometimes, once we get into the more complex identities, there are more than one way to do these. You might do it in 2 lines. I might take 8 lines. Depends on how you approach it and your strategy going down through the proof. Okay, so let's try this one. So left side is sine x times tan x, and right side is secant x minus cosine x. So I'll draw a line. Okay, so this line is replacing my equal sign because they're not equal yet, so I want to prove that they're equal. So on the left side, I think I will change tan x to sine x over cosine. What can I do to simplify? Well, I could just expand. I can't reduce anything, so I'll just multiply sine times sine over 1 times cos x. Now I'm going to go on the right side, because I can change secant to 1 over cos x. What can I do on this side to simplify? Well, I want to subtract these 2 terms together, so I need a common denominator, which would be cosine. So we'll multiply the top by cosine as well. So in the numerator, so the denominator is cos x. In the numerator, we get 1 minus cos squared x. So things to keep in mind with our identities. Always keep an eye on the other side. Always compare. So right now I'm comparing my right side and my left side, and I see that the denominators are the same, but the numerators are different. But I do know that sine squared x is equal to 1 minus cos squared x. So I have to change one of them. So I'm going to change 1 minus cos squared x to sine squared x. So one thing to keep in mind is don't go blindly down one side and start changing things for no reason. That's a big error in identities, is just randomly changing things when you don't have a purpose, right? Everything I do has a reason for it. I don't just randomly, if I see a 1, I don't just randomly change it to sine squared plus cos squared unless I need to, right? There has to be a reason for that. So just keep that in mind and always keep an eye on the other side and always compare. Okay, so when I got to here, that's as far as I could go, right? So I changed to cosine. I said, what can I do to simplify? Well, I could subtract the terms. So I will, and then I compare, okay? And by comparing, then I can decide what to do next. If I don't compare, I'll just randomly, blindly go down one side and change things for no reason. So there always has to be a reason to replace or change something. All right, let's look at this one. So left side is cosecant squared x plus secant squared x, and the right side okay, so just going back, because these are squares, right? But just keep in mind that if cosecant equals 1 over sine, then cosecant squared equals 1 over sine squared, right? And the same for secant and tan and cotangent. If cosecant, secant, and tan are squared, then so is the rest of it. Okay, so just keep that in mind. So let's go back to this. So on the right side, cosecant is the same as 1 over sine, and it is also squared. Secant is the same as 1 over cosine, and it is squared. What can I do to simplify? Well, I could multiply them together. I can't reduce, so I'll just multiply. So 1 times 1 over sine squared times cos squared. And then that's all I can do on that side, right? There's nothing else to do. So now I'm going to go over to the left side and see what I can do over there. So cosecant is 1 over sine, and it is squared. And secant is 1 over cosine, and it is squared. What can I do to simplify? Well, now I'm adding terms, so I could find a common denominator and add these together. So my common denominator would be sine squared x cos squared x. So this one needs to get multiplied by cosine, and this one needs to get multiplied by sine. And do the same in the numerator. So in the numerator now, I have cos squared x plus sine squared x. Now is a good point to compare, right? Now I'm done that, right? I've replaced my terms with sine and cosine. I've simplified it. I've done the same on the right. Now I'm going to compare. So in the denominator, I see they're both the same. So that's good. The numerators are different. But looking at my trig identities, I know that sine squared plus cos squared equals 1. So I'm going to replace this identity with a 1. So now left side equals right side. Okay, so make sure that everything makes mathematical sense. So when I read your solution or your proof, I have to understand what you're doing, right? One thing that happens with identities is a lot of magic happens and things appear for no reason or disappear for no reason, right? So the person, don't assume, so when you're writing your proof, don't think about that I'm reading it, think about that your classmate is reading it. So that person has to understand what you're doing, okay? It has to make mathematical sense. You can't just do things randomly just because you want it there, and that happens a lot. Well, I need this here, so I'm just going to put it there and hope nobody notices, right? So it has to make mathematical sense. So some of the strategies we've used so far. So we've always changed everything to sine and cosine. And our second step is always to simplify. So what have we done to simplify? In this one, we reduced. and we replaced, right? Those are two strategies. So we reduced here, and then we replaced a term there. What did we do in this one? So we changed everything to sine and cosine. What did we do to simplify? This one we multiplied. This one we had to find a common denominator. That's what we had to do to simplify. What did we do in this one? We changed everything to sine and cosine, and then we had to reduce. That's the same one. Let's go to this one. So what did we do in this one? We replaced everything with sine and cosine, and then we tried to simplify. On the right, we multiplied. On the left, we found a common denominator. Those are strategies to simplify. Okay? I'm going to do one more. This one's a little tricky. Sometimes we have to think. Usually when I do these, I kind of think in my head mentally, I kind of plan it out ahead. Okay, if I do this, what's going to happen? If I do this, what's going to happen? And remember that if you get stuck or it doesn't work, start again, right? You may not always get it the first time. It might take a couple of attempts or a couple of different strategies. So here's my reasoning, and this is a harder one, so don't panic if you don't really get this one, because we're going to go through a lot. So this is a harder one. So when I look at the left side, there's nothing really I can do, right? It's already in sine and cosine. There's nothing I can do to simplify. When I look on the right side, it's already in sine and cosine, okay? But the right side has a denominator of 1 minus cos x, and the left side doesn't. So that means I need to get rid of it, okay? Well, how can I get rid of it? Well, the only way I can get rid of it is if I reduce it. And the only way I can reduce it is if I have a cosine in the numerator. So this is my reasoning when I'm trying to strategize what I'm going to do. I kind of say, well, compare the two sides. What do I want to get rid of? Or what do I want to replace? What do I not need? Or what do I need? So on the left side, if I want to reduce this 1 minus cos x, this needs to be in cosine as well, so that I can reduce. So I'm going to change it to 1 minus cos squared. And then I think, well, 1 minus cos squared is a difference of squares. I could factor that. Because I know when I factor a difference of squares, I'm going to get 1 plus cosine x and 1 minus cosine x. And then I can reduce. Okay, so that's now left side equals right side. So that's an example of kind of thinking through it before I actually even write something down. So I have to have a plan. So my plan was, well, I want to get rid of the denominator, which means I need to reduce it, which means I need the numerator to be cosine. So let's change that. And then how can I reduce it? Well, it would have to be factored. And then I can do that. So that one is a good one because you have to think a little bit about that. Okay, so I'm not going to do any more yet, but let's go back to our strategies. So working down one side or both, but don't bring anything over. First strategy is change everything to sine and cosine, and then after that it's just trying to figure out what you can do to simplify, okay? We did some factoring, we did some common denominator, we replaced some terms. Okay, those are different strategies, and you'll see different strategies as we go through these. These ones are, except for the last one, these ones are pretty basic, right? They're really just changing the sine and cosine and simplifying. Okay. Also, I wanted to note that you may have received an